Welcome to Solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
So here we're given a pair of cesium isotopes and a pair of iron isotopes, and we're asked to predict which one is going to have a longer half-life. So the important thing to remember with this is that your half-life is an indicator of stability. So as your half-life increases, means that your atom is also more stable. Because your half-life is defined as the time that needs to pass in order for an amount of a sample to decay to half of what its original amount was. So to help with this problem, I have a screenshot from the book showing the neutron to proton ratio for atoms. The green dots in the plot represent stable atoms. The yellow dots in the plot represent unstable atoms. We're going to use this neutron to proton ratio to kind of help predict which of the two isotopes in question is going to be more stable. So if we consider first Cs-113, the neutron to proton ratio for Cs-113 is about 1.05, while the neutron to proton ratio for Cs-125 is about 1.27. So if we go over here to our plot, and we come right around where atomic number 55 is, we go up here, we can see that this is very close to this range where they emphasize that a neutron to proton ratio of 1.27 is more stable. So what that should indicate to us is that the Cs-125 is going to be the more stable species of this pair. Now we're going to use the same logic for the two iron isotopes that we have to work with. The neutron to proton ratio for iron 62 is 1.38, and the neutron to proton ratio for iron 70 is pretty high. It's 1.69. If we go into our table again, and we go over here to where 26 would be, we can see that both of these elements, their neutron counts fall very high above what we would predict to be stable for an atom like this. However, we're just asked to compare the relative stabilities. What we would predict from this, because iron 62 has a much lower neutron to proton ratio, we would predict this to be the more stable isotope between these two species.